So lesson 2, page 189, problem number 13. You have this water skier being pulled forward. Anyone here ever been water skiing? Yeah, were you able to do it?
Yes.
It's hard to get up on the water. That's the hardest part. You're down deep in the water, but once the boat pulls you, if you can get up, then it's not too bad. But so were you able to stand? Okay, it's tricky. Anyone else? Were you able to stand up?
Not really. It was really hard.
Yeah? Are you good? You can go around the lake? Oh, that's cool. Very cool. It's very strenuous on your arms because you're being pulled forward by your arms. You're holding onto the string. So there's this forward applied force.
Is he that good?
There's this forward applied force that's pulling you, across the lake or whatever water it is. So your arms get really, really tired. And they tell you that this water skier who has a mass of 70.3 kilograms is initially going forward 6.10 meters per second, roughly 12 miles per hour. And then the boat speeds up, and now the water skier is going to eventually be going 11.3 meters per second. And the question is, during this speed up, how much work was done by that forward applied force? And if you go to the work formula, if you say, hey, I know how to calculate work. If you take the applied force multiplied by the forward displacement times the cosine of the angle, we do know the angle because that rope's going to be pulling them forward. So the angle would be 0, and the cosine of 0 is 1. But we don't even know how far forward the person was pulled, so we don't know what x is, and we don't know what the applied force is. So it's kind of a dead end. So what's a poor physicist to do?
I use A equals mv squared.
Okay, and what does that have to do with work?
The change in kinetic energy equals the work.
Exactly. So instead of using this formula, the work done by the applied force equals the change in the kinetic energy. Yes?
Yes.
Okay. So if you calculate the kinetic energy at the beginning and you calculate the kinetic energy at the end, and then you take the difference, kinetic energy final minus the kinetic energy initial, you'll get the net work done. So that's what you have to do. So you're absolutely right. You have to find the initial kinetic energy, find the final kinetic energy, subtract them, and that'll tell you how much work is done.